Good day, everyone inside United Health and Optum. My name is Tom Rieger. Good day, everyone. My name is Tom Rieger, and I will give Zoom a chance to get everyone into the webinar today because it seems to have its own pace at doing things. But while we're doing that, I'll go ahead and move from my video to my screen share, and we will go from there. Like I said, this is a very intimate conversation between us here at EDB and folks inside the greater United Health organization. And I'm looking for this to take about 45 minutes today, maybe a little less, but we shall see. As I told someone in your organization an hour and a half ago, I'll try to minimize talking like a gerbil. But in saying that, we'll kind of start with some of the logistics. So again, my name is Tom Rieger. I'm your solutions engineer here for United Healthcare, the greater organization, which obviously includes Optum, United Health Group, and everyone under that particular domain that resides 6 miles from my front door here in the lovely tropics of Minnesota, which today is a lovely day. So this is only meant for people in your organization to attend today. Secondly, we do have a non-disclosure agreement and an MSA in place with your organization. So there are things I may talk about that fit under the category of, let's say, confidential. From a logistics perspective, if you have any questions at all, please enter them into the Q&A screen. Secondarily, everyone is on mute. This session will be running as quickly as possible. So if you have questions, please type them into the Q&A session and I will respond to them after the webinar is over. I find moments like this, questions tend to be very, very specific, which require very, very specific answers, which chew up time. And as I understand it, everyone's on a tight schedule today. This is being recorded and it will be put behind a password protected URL for you to consume after the fact if you so feel the need. And also these slides can be made available to you upon request. So we're going to talk very quickly about kind of databases and sizing and cloud, where we are, and quickly get into the sum of some efforts I think some of you have seen a precursor of from me personally around how we went out there and looked at all the primary cloud platforms and looked to try to identify what does not just good look like, but great look like. Because for you to move a tier 1 platform into a cloud requires a lot more than just turning something on. You need to have all types of other characteristics, both from a performance, but also a technical capabilities perspective. And we've uncovered interesting things here that also relate to the financial side of this. In fact, I just co-wrote a blog here about a month ago called Cloud Frame, where it feels like the cloud is now turning into what the mainframe was 30 years ago, where you had to measure things based on instructions per second, how many lines are printed on that green bar paper, on and on and on. And now we fast forward to 2021, and how the cloud vendors are charging you for things reminds us of the mainframe. But in those 30 years, we forgot how to write code and do real-time processing to appreciate needing to track those things. So you'll see in this presentation where I call out a lot of, let's just call it moments of financial inefficiencies when it comes to cloud vendors. I also understand that the primary cloud of United Health, the broader organization, is Azure. So I'll try to stay in that context. So I don't want to get too deep into this, but the cloud is not new, but it feels like we are now at that point where the bottom button says, the bottom bullet says it all. We're now looking to move those critical workloads up there. Moving things like an email or a Zoom environment like we're on right now, or Salesforce, that's pretty mom and apple pie. And it's not very high transaction rates, generally speaking, very distributed workforce, very network intensive. But once you start to really take on those things that are CPU, RAM, and disk intensive, like a transactional workload, like a database, it gets hard. That's where the hard stuff comes into play. And all of these vendors, if you look at each of them individually and in total, are somewhat kind of playing into that lock-in purview. They want to kind of get you onto their platform and they'll own you. Because especially a system of record where you have something persistently stored that's running your business, once you put it there, for you to take it out is a lot of work. So there's a bit of a land grab out there, but in that land grab, they're all taking things that are perceivably open source and open and somewhat proprietizing them. I'm making up a lot of words here on a Tuesday. So we decided to, within EDB, as the largest purveyors of Postgres, is how do you come up with a measuring mechanism, an understanding of what the different clouds offer? So we started by trying to understand benchmarking and sizing. So benchmarking from a database perspective, we are focusing and looking at the transaction processing council workload. For those of you who don't remember back in the day when I was working at Informix, which is a fun time, benchmarking became so prevalent as a proof point, it would end up being on billboards on the highway. In fact, this is an exact billboard that was outside of Oracle's world headquarters, talking about how we just beat them in a benchmark test. Well, fast forward to 2021, and there are other benchmarks out there that get kind of either database specific. So within the Oracle Enterprise, Manager, you can run a benchmark. SAP's got one, or we could go do little specific operating system types of benchmarks. But once we get to especially database benchmarks, they all seem to be out there on the internet for us to read at what I call performance at all costs, performance, not economics. And it reminds me, if you haven't seen the movie, I highly recommend it, Ford versus Ferrari. A moment where Lee Iacocca approaches Carroll Shelby in the late 50s because Henry Ford Jr. wanted to win 24 hours at Le Mans. And the one line in that movie that sets the tone when it comes to racing and benchmarking to some degree, what if I gave you a blank check? Now, I never get a blank check, and I know you never get a blank check. So we need to think about the financial aspects of sizing and going to the cloud as much as a raw number. So that's what we were doing here. That was one of the fundamental premises of this exercise. And with that, we also wanted to appreciate certain things that you would need from someone like us around sizing, because right now sizing still feels like it's like getting a custom suit at a department store, or if you're wealthier, at a custom men's store. And the problem with a custom suit is if you lose or gain a few pounds, it doesn't fit as well anymore. And like an IT project, if you undercut the suit, if you don't provision enough, then your users are mad. If you over provision or cut it too big, then finance is mad at you. So we want to figure out a more repeatable way to come up with a proper way to size things and to come up with a sizing mechanism from us to help you. So we turned it into t-shirts. So instead of going to the department store there at the shopping mall, wander out in the middle, get your coffee, and go into the Gap store and get a t-shirt. But we also found across different clouds, an extra large isn't always an extra large. What do I mean by that? If we then take this entire way of measuring things and turn the t-shirt sizes into technical t-shirt sizes, and we only have two variables, because again, scientific method, the things we learned in high school chemistry, if you're going to try something out, have minimal variables and maximum constants. So we took this entire effort to try to identify the best we could two primary variables, CPU and RAM, and everything else being a constant. Now you'll see here momentarily that's a little harder said than done, but we learned a lot along the way. So with that being said, one of the things we also found very quickly is the cloud will charge you for everything you use. What do I mean by that? There are four fundamental things we all need to do data processing: CPU, RAM, storage, and network. And of each of those, in a very minute way, they are properly cataloged and charged to you, whether you know it or not. So we need to appreciate that everything we're talking about here is not about performance at all cost, but performance from a price performance perspective, and how do we optimize that spend. And by using a standard workload, we did a lot of work when it comes to technical results and time studies and financial business cases. And in fact, some of the things have already come to fruition and are publicly available, and I'll send you those links afterwards. For instance, a fella in our chief technology office just completed the Terraform scripts to take all the benchmarking efforts that I'm about to show you and let you replicate it yourself for Azure. He's created Ansible scripts using the AWS call level interface to do this in Amazon. And we're looking to do that for Google Cloud as well. but all the while making sure we appreciate that in the end, we are all slaves to the accountant. I was raised by a CPA for a mother, and I learned a long time ago, son, nothing is free. So make sure you do the best with what you got. Now, I need to come up with an Azure example of this because it's actually uglier in Azure and it's somewhat a little more obfuscated than what Amazon does. But Amazon, as of when I checked this a couple weeks ago, they give you 44 choices of 8 core environments. And oh, by the way, all these cloud vendors also separate the technical definitions of all these different instance types from the financial aspects of these instance types. So I'm looking to bring those together. Now, there's a lot of reasons there's 44 different types, but most importantly, it's cost. Cost. And if we're going to go run a optimized OLTP database effort in a cloud, what is that one right answer there? That's challenge number one. The next challenge, and this is an area I know I've spoken with some of you at Optum about, is storage. And it isn't that storage is a challenge, but they give you a lot of choices. They give you a lot of performance reference points. And they also give you this term of max and up to, my 2 favorite terms. And I promise you, as a vendor to you, I would never do this to you, but max and up to. Now, this is using the assumption of, with our workload, again, a constant, how many gigabytes of disk am I provisioning? 600 gigs is the number I'm provisioning. And at 600 gigs, these were the max and up tos that I could ever hope to get from these different offerings. More importantly, in Azure, and I'll talk about this here in a minute, you have to buy it and provision it in kind of binary increments. And I'll talk about that here in a minute. What's the workload? So if I have a methodology, what's my workload? My workload is HammerDB. It is the open source, evolutionary, free community version of the original TPC-C for transaction processing and TPC-H for analytical workloads, a benchmark kit that you can go and download. In fact, I can send you, I have 3 scripts, how to download it and install it, how to load the database, and how to run the workload. But more importantly, what I like about it is it's database agnostic. So within each database, again, you have database specific workloads you can run against that database. But if you're really trying to look at things across a landscape, whether it be the platforms and the databases themselves, you want something that brings a broader support offering to that. And HammerDB does that because it supports these databases and more. Now, what's the anatomy of a HammerDB or a TPC-C benchmark? It's a transaction processing centric workload. It's about 75% reads, about 25% writes, aka lockings of the database. And you have 2 primary variables here. Now, the workload is a warehouse management system, as in customers have orders have items, orders get processed, orders get fulfilled. You can see where this is going from an OLTP perspective. And there's 2 primary variables to control the size of the workload. One is the number of warehouses, so the database size. And otherwise, the other one is the number of concurrent users. And all right, I'm having a movie analogy moment here. The second movie analogy for you outside of Ford versus Ferrari is Moneyball, the baseball movie. Now, even if you don't like baseball, you'll love the movie Moneyball with Brad Pitt because it's about the math. And it's about the math and the fact that you're limited by your budget to take on organizations that are 3 or 4 times your size. And it was about the Oakland A's back in the day. But what they did is they were looking to turn every baseball player, you think about statistics and quantitative methods, baseball is the dream sport. And take all that math and turn it into one number to define a player. Well, that's what we're doing here with all of this. Once you take all of the platform pieces and the Postgres and the workload over the top, it turns into transactions per minute. One number for us to work with. So within this effort, I want to call out that in what you're about to see here and what I'm about to discuss, and there's a lot more data behind this, is we decided to focus on 120 gigs in terms of total size and 96 concurrent users. Why, you say? Well, if I have 4 t-shirt sizes and I go from 4 CPUs up to 32 CPUs, I want to have a workload that won't kill the 4 CPUs, but will take the 32 to task. And this did that for us. Secondly, what virtual machines to use. Did a lot of trials and tribulations there because, like I said, there was a lot of details around what was the right VMs to use to do this benchmark effort. Thirdly, what storage to use and how to tune the storage. For instance, when it comes to IOPS or megabytes per second through throughput. Because everything has a cost. Everything has a cost. It can be just as easy for me to go out and provision the financially most expensive VM I could and financially the highest in disk I could to get a number. And you know what? I'm sure that will get me a really good number. But the cost for that number, compared to if I had half the resources and ran it again, which one's going to get you the right price performance? Finally, it's worth noting an observation point here too. The clouds are not all built alike in terms of CPU. In terms of their highest in CPU offerings in the cloud, these were the best that I could get across the three clouds. So I wanted to highlight that because I'm about to show some performance numbers that part of the reasons certain clouds may not be as performing as well starts at things like the CPU level. Finally, there was a lot that went on at the database layer. So far we've talked about the different components in the cloud to choose from and how to make those right decisions, the workload. Now we get to how do we load and properly tune Postgres. So since we are such an engaged organization around the topic of Postgres, I went out there and found the smartest people I could in my company. And some of these faces you see here in the very bottom center is Marc, our CTO. On the right is Tom Kincaid, Vic Fearing there on the right over in France. These are people whose fingerprints are on Postgres. So wanted to look at things like the configuration settings, how to break up and use the disk volumes the right ways to minimize IO contention, monitoring and measuring. And trust me, across clouds, it was not that easy outside of just going down into a terminal screen and running some commands. There were a lot of attempts and mistakes made to identify proper tuning. So again, if I'm going to have a lot of smart IQ people in the room, I got to make sure all the cooks have the right way to cook up the right results for me. We also did some internal, what I call mock trialing, where anyone who's ever had anyone they know who went to law school, inside law school, a professor will have students and they will have a mock trial over a particular case. Well, we did this here with these efforts, with everything from the methodology to the workload definitions to the results. And we would have, and again, motion picture reference number 3, you would have the protagonist and the antagonist. So of course, my job was always the protagonist, and I made sure that each people in these pictures here played the antagonist to some degree. And finally, we engaged some customers, including I've shared some of this with people who are on this webinar today. So I want to make sure that you also realize this is still an activity in flight. So if you see something out of what you're hearing me say on this webinar that causes you to have a light bulb moment, an aha moment that you think would be an interesting thing for us to take on for you, please let me know. Now, in the spirit of also a great degree of transparency here, we had a lot of runs that took place. We had HammerDB running on its own 4-way box outside of the database, so the databases themselves had their own servers. We ran over 375 Semper benchmark runs. And every time I would do it, I would drop the database, clear it out, build a new one from scratch, run the vacuum and analyze and start from scratch. Because in a lot of cases, it's very easy for you to run a benchmark run, stop it, and then just continue running on the same data set. And that's not accurate. That's not an apples to apples compare. I could not defend that in front of a trial. We also generate a whole lot of data. And you could see here from, 4 of my fundamental dimensions here as an old Bill Inman data warehousing guy. I love my dimensions. The different ways we looked at things from a concurrency perspective, t-shirt size, cloud, and database size. Another dimension also gets into running Postgres on its own VM versus single server versus flexible inside Azure, and so on. So let's get to some results. These results I'm about to show you are us taking Postgres, loading it on a VM, and optimizing the disk, the database performance, and the results. And here's what we have: small, medium, large, and extra large. Now, again, this is not about Ford versus Ferrari and me being Henry Ford with a blank check. It's about me respecting the workload I have here and coming up with an optimal result. So in saying that, I have all of these constants across the bottom. Again, 2 variables on the left, all the other constants across the bottom. If I look at my raw performance, my transactions per minute, again, my 1 variable coming out of HammerDB, Here's what I got from the smalls. Now you could do some math against the CPU differences I showed you in gigahertz and almost make these lines somewhat line up if you kind of weigh the average a little bit here. But where it gets interesting, especially, is when you look at price performance. Even after I had a chance to brutally optimize what I did with those darn Ultra disks in Azure, that was the cheapest I could get on a 4-way box, and it still gave me a lower performance number. Now, as I start to grow in size, things start to homogenize a bit in terms of both performance and price performance. You'll also see here too that it actually scaled quite nicely. In fact, I have more than linear scaling from my smalls to my mediums in every cloud. 16 CPUs. I'm now hitting close to, if not north of 10,000 transactions a second on 16 CPU cores and 128 gigs of RAM. And also, as you see here too, from a price performance perspective, I start to get even more, dare I use the word, homogenized. And then I finally get to 32 CPUs, and I got to almost 20,000 transactions a second. And here's my price per transaction. Now, there's all kinds of interesting things to ask out of the data here, either why certain things happened or why they didn't. But this is from this particular slice of data across all the constants and 2 variables, what we observe from a performance perspective, and then taking the price, annual price, that's an annual price divided by performance to come up with a financial number. Now, knowing that you are doing a lot in Azure, I wanted to call this out real quick. Is within Azure, you have Ultra disks. And again, these Ultra disks require a bit of discrete provisioning, and you have these IOPS and megabytes per second that you have for throughput. And also, every VM has its own limits. So here's the virtual machines I used, the EXDS V4, X, obviously the number is the CPU count, with the ratios of my t-shirts, and you have this thing called max uncached disk throughput. Now, they also have max cached disk throughput. That's only if you use their premium disks or slower. Uncached is what the Ultra disks represent. And you see here where the pricing turns into something, and I'm sorry, I used to actually have an equation up here in the slide, where if you start doing the math here, it's amazing how nickels and dimes can add up to a lot of money. And what do I mean by that? Well, if I look at my medium t-shirt size, again, 8 CPUs, 64 gigs of RAM, reasonable amount of power, I'm getting about 300,000 transactions a minute at 35,000 and 2,000 megabytes per second. But my storage price is over $9,000 for that. And if I take my total system price divided by my performance, I get 42 cents a transaction. Now, if the only 2 variables that I change now, again, in the spirit of chemistry and scientific method, minimize the variables you change to look at a different outcome. If I only tune down the storage, does anyone notice how little it's affecting the transactions per minute, but how much it is bringing down my storage costs and my cost per transaction? And it's worth noting here on a medium, right here where my mouse is kind of circling, that is what they called out is generally the max uncached throughput for a medium, the medium instance I used. But yet at almost half that performance setting, I got a better number at half the price. And oh, by the way, my total annual system cost divided by my performance, I drop by almost 5x. Not 5%, not 15%, 5x. By the way, I don't mean to just pick on Azure in this webinar to you. AWS is no lack of a sinner on this front either. Again, same constants on the left as I just showed you on Azure. And if I drop the storage characteristics of their storage, what they call IO2 storage. Now, unlike UltraDisk, where you have IOPS and throughput, the IO2 storage only has IOPS that you pre-reserve and pay for. You notice I go from 35,000 down to 3 here, and how when it comes to my throughput, I don't really start to hit a wall until I hit near the bottom of this story. Now, if I start to consider how much I'm saving for my storage, you notice too that on my cost per transaction, I kind of hit a pointing a diminishing return. And once I get to the bottom here, it actually starts to become more expensive again. So I've starved my compute with IO weights. basically, when it comes to my database performance. A couple of observations I have with Azure, specifically around their DBaaS offerings. One, it's worth noting that of the, let's call it around 350 tunable parameters of Postgres, I'm not able to change 155 of those within the single server. I think the flexible server is about the same, and I believe that y'all have done kind of the same thing I have. The single server, it's built on the 7-year-old Broadwell processor, which I don't think any of us would be willing to use that in a home computer, much less in a cloud-based tier 1 platform. And what still is very distraught to me is how you have no control over the disk's performance characteristics at all in their DBaaS offerings. In fact, they tell you right here, you get 3 IOPS per gigabyte for disk performance, which means, and I believe folks in your organization have done what I've done, well, if I just go out there and provision more storage from a gigabytes or terabytes perspective, and that increases my IOPS, that should give me better performance. I've tried it a half a dozen different ways. It didn't. It's also running on an old version of Postgres, 11.6. The latest version coming out, in fact, I think it came out this week, is 13.3. That now also between 11.6 to 13.3 means there's 11 security vulnerabilities that have been fixed since 11.6. Finally, the single server is built on Windows Server. Again, one of the time study components I did was whenever I tried to change any characteristics of the server and reboot it, because you had to do that, you have to hit the restart button on the single server. A restart, you could tell, was doing a complete hard reboot of the instance, and it took 6.5 minutes to come back online again. So if anyone has a 5 nines requirement, you can't even use single server. One reboot and you've lost, that fraction. Flexible server, I had more hope for. Flexible server, though, you can't even control or know what Intel processor you're using because they give you this V3 VM option. And once you start to look at what you get for a compute in that environment, and it gives you this very broad, abstract definition of chip families that spread out across 4 years of Intel architectures. So you're not sure what you're going to get from a compute perspective from flexible server. And it does at least give me a little bit more on the IOPS front, but they still limit you on IOPS based on how many gigabytes of storage that you provision. And again, I did that test as well, made no difference. And it finally is, at least I'm on Postgres 12. And oh, by the way, I say here in big, bold letters, you can scale up, but you can never go back. Instead of a movie analogy, I'm going to quote one of my favorite bands, the Eagles. It's like Hotel California. You can check in, but you can never check out. But it's true there in this case. These 2 screenshots were 2 of my more concerning screenshots that I found. In fact, I just went in before this webinar to look at kind of the build to EDB for the stuff I've been doing. And one of the things in the bill it calls out were the number of failed attempts to provision. In this bottom window here, I ran into all the time. At least one resource deployment operation failed. Please list deployment options for details. And it says does not have sufficient capacity for the requested VM size in your zone. So of course, as you know, in Azure, you've got different zones. And I tried East, Central, and West in the US, East 2, Central, and West, and kept running into certain environments that it wouldn't provision for me. By the way, some of these failures were against like 4 and 8, my smaller and medium t-shirt sizes. Very concerning. But the one as a DBA in my heart that really freaked me out was this bigger window here. This bigger window in the gray window, I'm not one who likes to read slides, but I have to do this. This notification is for upcoming scheduled maintenance to your Azure database for Postgres instances in Central US. This is scheduled to occur between, and if you look at the timestamp there, that's a 18-hour window of time on this particular day. During maintenance, your Azure database for Postgres instances will have a brief drop in connectivity. I think that's code for it goes away for a little bit and reboots. Feel free to refer to this portal for us to tell you what you will never be able to control or do when it comes to this environment. And here are my 3 particular t-shirt sizes that I was doing some things in. I was taken back. It's like you're saying that I have no control over an 18-hour window of time when you're going to basically do some sort of update to these servers and reboot them. By the way, when this date and time window ended out the other side, I went back in to look at the box. The Postgres is still the same version. Nothing had changed otherwise. So I don't know what they did to the environment because you notice they don't even tell you what they're doing in the environment. Oh, we're doing a minor Postgres upgrade. We're going to do this. Completely out of your control. Again, don't mean to harp on that too much more. Now, it is worth noting that what I showed you on that performance, price performance area was a representation of us trying to do our best efforts to get some numbers out of these clouds. But in the blue boxes, I also have a lot of data relating to doing that same thing around those DBaaS offerings. Just as I showed you on the previous slide, some of the observations I have with single server and flexible server, but I have that also inside AWS and inside Google. And I'm actually working on creating some different collaterals and such. But if any of you would like to drill in on the data, please let me know. And also, in the spirit of Azure, I was just looking to see if I wanted to take up the challenges of doing something in Citus. One of my challenges is once you start to get into some of these larger clustered environments, everything that we've done up to now from a consistency perspective was a single server, so there was no replicants. There was no, from a pricing perspective, backups, encryptions, or anything else. And so once you start to get into some of these cluster environments like a Citus, or if I start turning on some of these things like an Aurora, you now have network consumption, you have network costs, you have other zones costs, you have, how do you then start to compare apples to apples of, us provisioning something in Azure versus Citus, if there are certain things that either we can't do or Citus won't let us do. So just wanted to, my heart to yours, some of the things we're also looking at, along with, this is actually a request from Optum, is we're looking to do some more analytical things in the cloud with an analytical add-on to Postgres called Swarm 64. So we are taking that up immediately. I have the license and have a direct contact into Swarm 64 to do that. So expect more on that front to drive more of an analytical workload in the cloud for you as well. So in the spirit of time, and by the way, I see Curtis, you're on here. So everyone, Curtis Cavett did a nice job at calling me to ask me how long this is going to go today. And I said, oh, high in 45 minutes. I'm looking to actually give you a little bit of that back because I wanted to make sure that everyone had an appreciation, again, for the process, the data gathering, the data analysis, and what you saw from some observations and data presentation. Going further, though, I'm looking to take it to the next level. So on June 2nd, actually maybe June 4th now, so it's being flushed out literally today, I'm going to run what I call the Postgres 500. Now, for those of you who are into auto racing, realize the previous Sunday is the Indianapolis 500. So after Indy 500, after Memorial Day, probably on June 4th is where we're leading to that Friday, I'm going to do a live apples to apples benchmark of AWS with EDB, AWS with RDS, Azure with EDB, and Azure Flexible Server. Now, yes, I may have had some enjoyable editorial license in the visuals of what these cars look like that are competing in the race, but I wanted to make sure you realize that during this webinar, we will describe the workload, kick it off live, talk about the workload, talk about observations, go into both Azure and AWS's monitoring tools to look to see how, dare I say, the cars are running from a gauging perspective. And when it's all done, take the results, the transactions per minute, and plug it into a financial calculator so you can see not just the methodology, the data gathering, but how you can take the results and come up with what makes sense from a financial perspective. So I wanted to make sure you knew that all of you will get an invite from us in one way or the other when this is ready to go. So deliverables. There's some of these already in flight right now in rough draft form when it comes to how-to guides, technical guides. And I mentioned the scripts to allow you to go and do this yourself, whether it's on AWS or Azure. I need to check with that CTO person who is photoed in my smart people around that one image, Marc Wong. And then also, how do we turn this into a proper kind of smart Excel spreadsheet or smart calculator to help you get the debits and credits right, the financial side? Because all of the best transactions per minute in the world, I know what my mother, the CPA, would have said, what's it cost? So to come up with that total annual cost and also that cost per transaction so that your organization can optimize the technical and financial spends. So key takeaways from what I just talked about in the last 35 minutes. One, cost per transaction, the efficiency of the effort is paramount. Secondly, we have found too, in almost every conversation I have around this topic, every client is either over provisioning what they use in the cloud, or they didn't know that they were potentially over provisioning. I have found very quickly, and Azure's the most guilty party at this, is there's a lot of strict things you can and cannot do when it comes to tuning and controlling what you can do to your environment, and also how you can monitor it. In fact, a lot of them, especially like in AWS, their primary monitoring tools of choice are the ones you pay them for from a monitoring perspective, like CloudWatch. I mentioned the single server so passionately on purpose because I was not awestruck, I was floored by the fact they're using such old CPUs, such slow disk, and such an old Postgres in provisioning that. But even as you go to the flexible server, you're not seeing that much better of an infrastructure used to create a high-performing database server. And I would like to know if, from what I just described to you, if something came up, because as a strategic client of ours here at EDB, I want to make sure that what I am doing here, I feel like a cook in a kitchen. If you don't like the cooking, I got to change the recipe. So I want to make sure that what I have mentioned today was of interest. And if you had any interesting aha moments that you would like to see us do on your behalf, let's call this a benchmarking center of excellence as a service for cloud. I got to come up with a better name. But there's more to come, as I mentioned. There's also other things we're thinking about too, which is if disk is such an expensive part of the exercise, what if we over provision the CPU and the RAM, tune Postgres for taking to minimize the IOPS in some fashion to see how I can manipulate the efficiency of the cost. But these are all kind of like little petri dish moments we're just thinking about. So if you don't know EDB, we are the primary purveyors of Postgres to the world as a pure focus. I wake up every day thinking nothing about Postgres. And that means from a support perspective, from an education perspective, in fact, a lot of what I just described to you, I'm working on creating a one-day class around this effort so that organizations can take, again, the methodology, the gathering, the best practices, and take those away as a certifiable tool in their toolbox. We also bring a lot of professional services to the front. We also bring to Postgres a lot of tools around Postgres to make those tier one requirements a reality in open source land, whether it's on-premise or in the cloud. Platforms are very important to us. Again, platforms isn't just about loading Postgres and going. What if you want to play with containers? We have a new cloud native Postgres. What if you want to find the right way to provision something in a cloud to do those big tier one things? I spend a lot of time talking to organizations who are looking to port their solutions to Postgres. So maybe with an Optum, you're working with a certain off-the-shelf app. For instance, I know when I worked at Documentum, you use a lot of Documentum and you have the wherewithal to have ported that to Postgres from a metadata storage perspective on the back end. Or maybe you have other solutions you're working with that are running on Oracle or SQL Server, and you're trying to move those to an open source threshold. Finally, focus. I'm a big believer that focus wins every time. And that's what we bring to the table here is the focus, the dedication, and also the full complementary relationship we have with the open source community and how we give back. For instance, if we have a tech support issue that comes up that was a bug fix, there's security vulnerability to the kernel Postgres, we donate that back into the community. So that's who we are. It's also worth noting, if you haven't signed up for Postgres Vision on June 22nd and 23rd, the registration is open now. It is totally free, which I'm sure from a pricing perspective is the right price. But there is a lot that will go on those 2 days. In fact, I just found out yesterday that I will be giving a presentation, a breakout session. So I look forward to you also signing up for Postgres Vision as the largest independent Postgres user conference in the world. So with that being said, if you have any questions, if you don't know how to find me, I will make sure when this is over, I will send a note to you so you know where to find me, because I want to make sure both, if you have a question or a comment, you can enter it in the Zoom area now. That will find its way to me. But also, if you have any questions at all going forward, don't hesitate to reach out. Your account representative is Brian Moriarty, and here is his email address. I sit here 6 miles from your world headquarters here in Minnesota, and am in a position to do whatever is needed for your organization to help get you the right knowledge, get you the right help, or get you the right technology. So with that being said, that is all I really wanted to go over today. It is now 40 minutes after the hour. Curtis, I kept us on time. Thank you very much. And otherwise, I will call it a wrap. Thanks, everybody.